Good morning, everybody. A very warm welcome from my side. My name is Axel Sikora, Chairman of the Embedded World Conference, and I very warmly welcome you to the second day of Embedded World exhibition and conference. Yesterday I found it awful. There were so many people. It was so busy. No, it was great. We, on the conference side, I believe, had a very good first day, had the first third of 81 sessions. So 200 something presentations and 17 classes that we have all in all. And yesterday already we had a keynote around AI on the edge. And in that, which was from Dr. Salil from AMD. And there we already saw different verticals. And today we'll take a deeper look into one of the verticals. In the second keynote, or second day keynote, to be precise, where we'll learn about how the intelligent edge may help enable the sustainable factory of the future. And I believe, for me, this presentation combines two very important aspects that we also highlight here in Nuremberg since a couple of years. One, of course, is the edge AI, embedded AI. This, of course, is one of the core topics, core hot topics of these days and years. And the other one is, of course, sustainability. 2 years ago, we had an excellent keynote from IEEE 7000 around the sustainability issue, and try to keep this on track because it's an important, very key feature for the future. We are very happy to have an excellent keynote speaker, Fiona Treacy, from Analog Devices. And let me shortly introduce her before I ask her to the stage. Fiona is Managing Director with the Industrial Automation Business Unit at Analog Devices and leads the Isolation and Safety Systems Business Unit, along with business strategy team focused on accelerating customer development. Previously, Fiona held roles in engineering, applications, marketing, and business management within the factory, automation and process control, industrial connectivity, precision converters, and instrumentation business units. Fiona has a bachelor in applied physics and electronics and an MBA from the University of Limerick. And later on, she will introduce a co-speaker, and this, I believe, is another excellent choice that she took, which is Fabio Violante, CEO of Arduino, and Fiona will introduce him later on. It's a great pleasure to have both of you here. So, Fiona, please.
Thank you.
The stage is yours.
Thank you.
Thank you.
Morning, all. Are we all excited for day 2? It's a room full of engineers now. Come on, we'll try it again. Are we all excited for day 2? So we're living in a time of extraordinary change, and every individual, every business, every sector is being impacted by the power of AI and computing power at the edge. And in this 4th industrial revolution, and even into the 5th industrial revolution now, it's spreading across the globe with increased speed. So let's find out how we can take advantage of it in the industrial sector. So industrialization has been a strong force for good. It has created the American middle class since the 60s. It has lifted over 800 million people out of poverty in China in the last 40 years. And it has caused an explosion in global trade. But this growth has come at a cost, and it's actually come at a cost to our environment. So what we see is that the industrial model is currently failing our planet. We create about 7.6 billion tons of industrial waste in the US alone annually. A lot of the energy for the sector still actually comes from fossil fuels. It's a very hard to abate sector. And if we think of the supply chain journey, which is quite complex, of a simple product, like a pen, that we might use here in Europe. It has to traverse 12,000 kilometers around the globe from where it might have been made in the East. So imagine the carbon footprint, the unnecessary carbon footprint of that. We also have challenges in Europe around workforce shortages and skills shortages. So technology holds tremendous power to transform how and where we're going to make goods in the future. But we have to act now. So I think it's a once-in-a-decade opportunity for us to re-establish the industrial sector as a strong force for good. But it's not going to be easy, because 50% of energy is actually consumed right now within this sector. And that includes the commercial buildings, so like the big building we're in here today in the Messe. And that, when we look at energy demand, what we see is actually energy demand by 2050 is actually going to double. So we're going to need twice as much energy as we do today. Now, of that energy demand, a quarter is going to come from renewable energy sources, and ADI and all of you and others are investing in innovative technologies to enable this pivot towards sustainable, renewable alternatives. But what's really interesting here is the fact that the big box at the top is half of it is going to have to come from efficiencies. So using the energy we have today more efficiently. And that's why this is the focus of this presentation, is around driving efficiencies and productivity optimizations. So simply put, for every joule of energy we use today, we need to be able to create 2x the output in the future. So imagine the scale of change that's needed to do that. And then if you compound this with society's demand, we all like now personalized, customized goods. So this is the scale of transformation that's needed over the next decade. And it's both a daunting, but also an inspiring challenge and call to action for all of us in this room. So let's find out how we're going to do it. So we need to fundamentally rethink how we operate. We need to fundamentally think and change how we make things, how we build things. It demands re-architecting systems from the ground up for efficiency. It requires re-engineering our factories to deploy more automation and robotics so that we can drive flexibility. And this will enable a move towards hyper-agile manufacturing, which means we can green shore and make more goods closer to the source of use. Now, the good news is that it's fundamentally an engineering problem. And what have we got in the room? Have we any engineers in the room? Anyone? So it's fundamentally an engineering problem. And that means we can engineer our way out of this solution, right? We can orchestrate the combined power of advances in sensing, actuation, precision measurement, and computing power and intelligence at the edge. So the answer really lies at the edge, in capturing real-world analog signals and interpreting them to drive a data-driven transformation. So we can leverage this data to better understand power and energy use within components, within systems, most importantly between systems, and from machine to machine. But the issue is, it's hard to understand where to start, right? It's hard, there's a whole lot of things we could do, and where do we get the most return on investment? So trial and experimentation is needed. And that's where I invite Fabio to the stage, because he has excellent ideas on how we can accelerate experimentation and also how we can help validate what are the best potential opportunities and solutions. So Fabio, our CEO of Arduino, thank you for joining us.
Thank you very much, Fiona. Good morning, everyone. So we are a lot of engineers here at this conference, and it's always a pleasure to be here. It's an event where we reconnect with our peers and then network. But I think that Fiona mentioned the sustainability issues and the problems for the environment. But we also have a big challenge as an industry, because basically we are all aging, and basically this is something that is inevitable. And if you look at these numbers, so we have minus 4% of people in our industry because they are retiring. And also the number of new electrical engineers and engineers in the fields we cover as an industry, they are going down. The only area where people and engineers are growing is the software side, because software is becoming ubiquitous in everything we do, and we have software define everything. So if you look at the automotive space right now, is more, let's say, advanced than anything else that we can imagine. But also the factory is becoming a new environment where everything is going to be software defined. We see robots that do a lot of things. quite interesting that allowed for the efficiency that Fiona was mentioning. But we have a talent gap that is pretty big, and you may be familiar with Arduino because we have a huge community, more than 40 million people visiting our website every year, 33 million people downloading our IDE every year. So these are big numbers, but what we are seeing is that a lot of people that started with Arduino at school 10, 15 years ago, they're now going to work. And these are not the type of PhD style or super sophisticated engineers, but they're really passionate about problems, and they bring a different perspective, and they can cover, let's say, a little bit the estimated talent gap. We see this every day in our life. So, and the point is very simple. So all the companies we are approaching, now we have Arduino Pro that is basically dedicated to go from prototyping to production, so helping professional customers really use the same ease of use that they enjoyed when they started with Arduino. But the issues in companies and factories and for sustainability are always the same, basically. So people need to be fast in prototyping. Companies need to have very short development cycle. Nothing that can be compared to 4 or 5 years ago. There is really a huge need for showing quick result, being outcome-based, being more agile, and we keep hearing this. And as an industry, we have to think about this aspect because we cannot always go to our business stakeholders and say, okay, this is going to be another 3 years project, because the companies don't have the time. The change needs to happen quickly, and we have to be supportive of the business as much as we can. And there is also a big problem of security. Security is entering the factory space, operation technology and IT technology. They have to be more cooperative, and we have to be very, very, very cautious about what are the challenges. So the other point is, how can we scale rapidly? Can we afford to have incredibly long lead time, shifting goods from one area of the planet to the other area just to save $5? So that's the kind of challenges that we have. So what we propose as an approach, as an industry, and we are trying to push in terms of investment, is the open source approach, where some of the things we do can be made open for more people to participate in the development cycles, to democratize the core complex technology that we use, while combining, for example, with proprietary IP. So we mentioned Edge AI. In Edge AI, there is a lot of things that can be done, and probably a lot of investment to go into there. So what we are doing at Arduino is a combination, let's say, of what we can create as a platform for open source development in terms of hardware open source, software open source, development tools that are open source, with also proprietary technology that are the secret sauce that your company as vendors or as enterprise can contribute. And in terms of the tools that we that we can think about as an industry is to go to more modular approach with more system of modules. We are pushing, for example, very hard towards system of modules also for microcontroller, for Edge AI, for miniaturized sensors, etc. But we are also somehow breaking some taboo in the, let's say, for example, PLC space, where we are opening up the world of PLCs with more finished products, like the one you see in these pictures, where the idea is that, of course, you have a piece of equipment that is secure, that is robust, that is strong, and can be suitable for enterprise application. But we give freedom to people to program it using, for example, our framework or the traditional languages, or a combination of the two. So this means that you know what is inside the box because it's open source, but you can also broaden the number of people that participate, because especially in this last area where there is a huge need, is the area where the skill gap is becoming bigger, because it's very tough to go to a kid, 16, 17, 20 years old kid, and say, okay, Now you will learn the ladder logic. So they want Python, they want other type of languages, they want more modern language, Rust, whatever technology is the fashion technology of the moment. So we have to rethink the way we do stuff because we wanted to tap into the 20% software engineers that are growing. We wanted to tap into a broader engineering, let's say, space. And as professional, we can build the shovels to go for searching the gold, and I think we have to so that we can increase the opportunities. So, in my opinion, and I stop here. So I think one of the things that we have to think as an industry is that we love as engineers, and I'm an engineer, I have a PhD in engineering, but we love to, let's say, reinvent the wheel every time. And in embedded system especially, I come from the software space, but in embedded system, you know, we spend 70% of boilerplate code to just bring up a board that does nothing application related. And then the minority of the project time is always spent into, let's say, focusing on the application, the problem we are trying to solve. We have to revert this equation so that we can, let's say, through modularization, through open source, through whatever comes to your mind, we have to say, okay, let's keep the problem more close to the application rather than the technology per se. So, Fiona, I think that I tried to give a perspective from the open source. Of course, I will be available for questions after the end of the presentation. Thank you very much. Slide. So just
I was like, if he's going to make me present this, it won't be good.
just one comment. So this thing is real. So we have real customers like Steelcase, for example, that is an industrial company in the US, furniture maker, that is using this open source approach for their problems. Sorry about the mistake.
So I guess as Fabio outlined, we, you know, if we want to solve this efficiency problem that we've been talking about, we have to look at, you know, re-engineering some of these systems and the way we operate. So if we zoom out and look at the industrial or the manufacturing operation at a bigger scale, we can identify a number of key areas that we can invest in to drive efficiency optimizations. But I guess there's lots of different areas. Some of them are really big capital investments, right, which have big return on investment. But others are smaller retrofitting type opportunities that have, you know, compounding effects in terms of efficiency gains. So I'm going to maybe just talk about three of them in a little bit more detail. So first, zooming around the factory, when this came up first, was a number of AMRs, autonomous mobile robots. And these are used for automated material handling, so they're moving the products and they're moving the raw materials. And what we see is that through advances in vision sensing and wireless connectivity, these devices can now safely move around factories without the need for physical guide wires or markers. So through advances in vision and perception, they become real-time aware, and that means that they can actually optimally plan their route around the factory without having a pre-planned route, which was traditional. But every factory is different, so a level of customization is always needed. And with customization comes cost and comes time. So what we're seeing in the industry is a move towards making more complete modular systems for core functional groups within a robot. So you might have a platform, let's say, for your battery management system, for your precision motion control for the wheel drive system, for your vision in particular, so for awareness, real-time awareness and perception, you could have a sensor fusion module that would use LiDAR, maybe radar, and 3D time-of-flight depth sensing. Also within the robot, you need to connect all these things together through backplane, so really high-speed GMSL type connectivity platform, and a wireless platform to get back onto your OT-IT network in the factory. But what is the glue that's kind of stitching these hardware platforms together or making them interoperate? And that's the ROS robotics operating system. So this is not an ADI thing, it's again an open source set of platforms. And it's what makes modules from different vendors work together, stitches them together. So the other thing we saw on our factory was a number of more traditional robots, pick and place machines. And they've stopped moving now, but they were picking and placing. And traditionally these were in cages, right? And again, through edge AI and sensorization of our robots, these robots can now safely interface with humans. So what they can do through real-time awareness, they're able to sense the position of a human within their workspace. And based on the motion and activity of that human, they can automatically adjust their performance. So they can slow down, they can speed up depending on what the human is doing. And this is versus traditional architectures where they would have had very linear safety curtain type systems where they've actually have to be shut down or powering on and off continuously. So it's much more efficient. And that takes me back to the actual production line itself. And what we see in the production line is more and more moves towards edge-based intelligent sensors and actuators. And these enable us to capture insights into the operation of the factory and to drive improvements. And what we see is more and more intelligence being driven onto localized areas within the production line. And that has the huge benefit because the equipment itself become more responsive. And now we're actually able to run, as many of you will know, efficient AI in battery-powered sensors. So this is very important when we talk about retrofitting. So we can use Edge AI in some of these factory applications, maybe to add security for facial recognition before you can change the configuration of a machine, for object detection and orientation on a production line, or for machine health monitoring, something like smart motor sensing. So these three concepts and multiple others come together to make this idea of a dark factory. And a dark factory basically means that it's all automated and it has minimal human intervention. So you might think it's a utopic vision, right? Because it's the idea of that it can run dark, as the name suggests, it doesn't need lights, but it is actually closer than we might think. So the problem is not greenfield deployments. New factories, they've state-of-the-art equipment. The actual issue is how can we effectively retrofit brownfield factories? And this is through the deployment of digital connected factory architectures. And these factories are, digital factories are effectively doing two things. They're capturing data and sensor insights to inform decision making, and they're deploying automation and advanced robotics to drive productivity. And these two things combine to drive productivity improvements. So a digital factory consists of three key things: seamless connectivity, adaptive control, and intelligence at the edge. And each of these areas are going through improvements and changes as the factories are retrofitted, particularly these brownfield installations. And brownfield comes with key constraints, right? Space is constraints. They're old factory buildings. Space is at a premium. We know it in our own factory in analog devices ourselves. And the other thing is there is constraints around the cabling, infrastructure within these factories. So I'll briefly mention areas where there's upgrades going on in each element. So Connect. So Connect, we have now all this volume of data. So it's great that we talk about this diagnostics data, extra parameterization data, but we need to be able to enable all of this data to flow on the one network. So they have to be upgraded for bandwidth. They have to be upgraded for determinism, because we need to manage and enable that control traffic, so critical real-time traffic within the factory, which is mission critical to the operation, with all of this additional non-mission critical data in a way that ensures control traffic is never compromised. And the third thing is Ethernet to the edge, or IP addressability of all of this great intelligence that we have within our production floor. And the big breakthrough here is this 10-base T1L technology, which enables Ethernet over long reach, so over 1 kilometer. But the real breakthrough is that it can use the existing cabling infrastructure within the factory. So it can run on single twisted pair of cables, which previously would have ran traditional 4 to 20 milliamp type analog signaling. Control networks are also getting upgraded. So control, what we see is a move towards software configurable, and Fabio mentioned it, software configurable automation. So what was fixed function platforms, they might have been analog, digital, inputs, outputs, now they're software configurable. And this means that we can configure and change the production environment flexibly in real time, and we have minimum amounts of downtime. And the minimum amounts of downtime means that you can have much smaller batch sizes. So it makes it more viable to make goods closer to the source of use in terms of green shoring. The other thing on control is this move from rack-based, big centralized cabinet control systems to decentralized systems, so deploying the motor onto the drive itself. And again, here we see this drive towards miniaturization becomes critical. The third area is interpret, and we mentioned about capturing intelligence at the edge, and that's to drive equipment effectiveness, to drive yield, and some of the areas we see investing in is, machine health monitoring. So the ability to monitor a piece of equipment and to understand that it's always operating within its zone of maximum efficiency. So it's not getting hot, it's not burning excess energy. And through localized machine learning, we can then signal, corrective action, really quick corrective action. So we haven't wasted a whole batch size where we have a whole load of defective product and we've wasted a whole load of raw materials. Again, with a lot of these condition and asset health monitoring platforms, they need to be non-invasive. They need to not affect the performance of the asset onto which they're deployed, and miniaturization comes into play. So that brings me to the conclusion, I guess, of this presentation. And hopefully you have seen that through the challenges are many, right? We talked about efficiency, we talked about flexibility, worker shortages, the need for faster deployment. But a solution is possible, and the way forward is clear. And at ADI, we believe that through collaboration across disciplines and across partners, we can engineer our way out of this problem. We can engineer system-level solutions to these complex challenges. And we can enable faster adoption of some of these innovative technologies that ADI and others are developing and bringing to the market. So it's a big challenge to drive 2x energy efficiency. It's something that is a huge transformation in the sector. It excites me, and I know it energizes our team back in ADI every day. And together, we can achieve a 2x increase in efficiency through seamlessly connecting, adaptively controlling, and intelligently interpreting the factory floors of the future. Thank you.